Hi everyone, this is the quadratic function and the discriminant. So these two things are really useful for difficult quadratics that don't look like you could easily factorize them. The quadratic formula is this one up the top here, minus b plus or minus the square root of b squared minus 4ac over 2a. And that bit under the square root sign, that's an important bit called the discriminant, and it tells us how many solutions there will be. So if that has a value of 0, it pretty much disappears from the equation and we get one solution for x. If it's positive, then we have two different values, and because it's that's because of the plus and the minus, we have to add the square root of that number and subtract the square root of that number. And if it is a negative number, well, we can't find the answer to the square root of a negative, and so therefore there's no solution. So here are some examples. In the first example, we've got something x squared, something x, plus a constant term, it equals 0. That means we can apply the quadratic formula. A is your negative 6, b is negative 1, c is 2. When we put that into the quadratic formula, we end up getting our two answers of negative 2/3 and a half. So you could factorize this one and get the answers that way. And being a difficult factorization, it's probably saving you a little bit of time using the quadratic formula, but not much. You'll notice that where we've got the discriminant coming out to a perfect square of 49, that means that we can find the square root of 49 as 7, and we're going to get numbers without surds in them as the answer. It's a positive discriminant, so we get two solutions. In the second example, it's fairly similar. The main difference in this second example is that we're not starting off with a formula, quadratic formula equaling 0. So we have to move the 4x and the 12 across to get it equal to 0 first. And then after that, pretty similar to the first one, where we get a positive discriminant, so it's two solutions, and in fact it's 64, which is a perfect square, so we can get two integer answers. The next example, we get the discriminant coming out to be 17. Now we can't find the square root of 17, so that just means we end up with surds in the answer. The last two examples are where you have a discriminant that is negative and where you have a discriminant that is 0. So when it's negative, there's no solutions, can't find the square root of a negative number. And where the discriminant comes out to be 0, that only happens if you have a perfect square, by the way, that's where you have only one solution.